I'm going over the 1982 free response question. That was the last question on your combustion hydrate worksheet. So the first thing you want to do with a problem like this is write down all the information they give you and continually refer back to it, or you'll get lost in your problem. So it says we take water, we combined it with uranium fluoride, which is this compound here, and they gave us the total mass. And this mass right here is what we started with, so all the fluorine we started with has to be distributed between these two products. It also says when we combine this, we make a solid that contains uranium, oxygen, and fluorine, plus a gas that contains hydrogen and fluorine, and we don't know these subscripts, so go figure, we're going to have to figure them out. This is a gas. It's 0.970 grams. They also told us it was 5% and 95% hydrogen and fluorine respectively. So in your problem, they decided to take 5 and multiply it times the amount, turns your gram to moles, and that's fine. That's perfectly fine. But when I just do quick, easy empirical formulas, if they give me the percent, I assume 100 grams, and so that's 5 grams, 5% of 100 is 5 grams, and 95 divided by the molar mass. We've got a molar ratio. That's not a half, a quarter, 75%, a third, a sixth, 2/3. So I can round that up to 5, and I get a 1-to-1 mole ratio. Okay, so the next question asks us what fraction of fluorine is in the solid and in the gas. Okay, so that would be the percent in solid, percent divided by the total amount of fluorine that we started with. And again, that fraction's a percent. So first we need to find the total grams of fluorine. That's your whole, right? That's how much fluorine we started with up here. Okay, so my original mass was 4.267 grams. That's my reactant. And then I'm just going to do mass percent. In the problem, they took that grams, they made it into moles of the compound, and then for every 1 mole of this compound, there's 6 moles of fluorine, and they turned it into moles of fluorine and then turned that into your molar mass. That's how the key worked. I just like thinking of it in mass percent. So what's my total molar mass is, if I add those two up, remember it's 6 fluorines, I get this for my total molecular weight, and now I can just do part over whole. Fluorine is 114 grams is the molar mass of 6 of them, divided by my total molar mass. I get 32.38%. Remember to multiply in decimal form times your total mass that they gave us of that reactant, and I get my total grams of fluorine that I started with was 1.382 grams. So then my fraction of solid and gas would be how much of the solid over total, how much of the gas over total. So in my gas, they did give us 95% of fluorine, okay? Let's make sure this is my fluorine gas so you know, times the times the mass that we started with right here. And that gives me 0.9215 grams of that gas, of the fluorine part that's part of that gas. And if I subtract that from the total, then I get how much fluorine was in the solid, which is 0.460, and now I can do my fraction, which is 0.9215 divided by, this is for my gas, divided by the total, 1.381 fluorine total, and that gives me 66.7%. Now, I can then do my solid over the total amount of fluorine, or I can just subtract this from 100, and it's 33.3 in my solid. Okay? So now we have a lot of different masses going on. This is the mass, the total of my fluorine that I started with. This is my fluorine part And this is my fluorine part, that's the solid, and we need to make sure we know which masses we're talking about. So the next part asks us to find the molecular formula for the solid, and we know the total grams in the solid is 3.730. And if I'm finding my molecular formula, percent to grams, grams to moles, divide by lowest, then make whole. So we need to know the grams in this solid, okay? And we figured out the grams of fluorine already in the solid, which is 0.460. And so now we need to figure out the uranium. Let's start there. And if we go back to our original, I have how much uranium is here. I can figure that out. And everything that I put in to start is the same mass that's here. Why? Because it's nowhere else. So all the uranium here has to be the uranium there because of my law of conservation of mass. So when I go back, here's my total reactant, and we know the total grams of fluorine. We've already calculated that from our last problem. So if I subtract the total from my fluorine, I will get the grams of uranium, okay? I don't like how this is worded. This is what I'm looking for. Okay, this is my step. But this is my total reactant minus the grams of fluorine in there gives me my grams of uranium. Okay, so now I know my uranium, so I can put my grams right there. So now, if I know the total amount of my solid, which is UOF, or UFO as I put there, and I already know my uranium and I already know my fluorine in that solid, I can subtract those two and get my oxygen. So you need to make sure that you take your total solid, and then I take my grams of fluorine in the solid. This is how many grams are in the solid, not your total grams of fluorine, not the grams of fluorine in your gas. So be careful there. And then we found out our grams of uranium, and once I subtract those two, boom, boom, I'm left with my grams of oxygen, and I can plug it right into my handy dandy empirical formula chart. I can convert it into moles. I can divide by my lowest, and I have a 1 to 2 to 2 ratio, and this becomes my empirical formula. And I left it UFO because that's fun. Okay, so a little different than how they did it. We're coming at it the same way. Either one's right. You should figure out what makes sense for you.